In this video, I'm going to explain how to complete page 5 of the activity. On page 5, you're going to be redoing the same experiment, but with a slightly different procedure. So on page 5, you actually don't have to fill in the initials of your 12 people, and you don't have to fill in the initials for group 1 and for group 2. You can leave all of those lines blank because I'm going to have you pretend that you have the same 12 people and you have the same 6 people uh, in each group. So the participants have not changed. So that's why you can leave these 12 blanks, um, just leave them blank, and leave these 6 blank, and leave these 6 all blank. But for independent variable, um, write the name of the same independent variable that you had before, whatever it was, and write the same 2 levels um, from page 4. So the independent variable and the 2 levels stay the same from the previous page. And once you fill those 3 blanks in, go back to these 3 extraneous variables. And once again, either control, balance, or make it a confounding variable for each one of these. And the directions have changed um, from page 4. So look at the directions that I shared with you, and that'll tell you which one is supposed to be balanced, which one is supposed to be controlled, and which one is supposed to be a confounding variable, and just follow the directions again. Just like before, it's up to you what numbers you want to pick, as long as you follow the directions for balancing, controlling, or making it confounding. Then make up 12 more exam scores, like you did last time. And um, so this is supposed to be a new set of exam scores, not the same exact exam scores from page 4, because here we're imagining that we're doing a new experiment and we're collecting a whole new set of data. So make up a whole new set of 12 exam scores. And it's fine if some of them are repeated. For example, if you had a 75 on page 4, you could have a 75 again, but don't just copy and paste the same 12 numbers, because it's a new data set. And just like before, calculate the mean of group 1, add the 6 exam scores, divide by 6. Do the same thing for group 2, add the 6 numbers, divide by 6 to get your 2 group means. Then once you're finished with that, I want you to make a bar graph for your group means on page 4, and another bar graph for your group means on page 5. And when you look through my directions, you'll notice that page 4 didn't ask for a confounding variable. So on page 4, your 3 extraneous variables will all be either balanced or controlled. None of them will be confounding. And on page 5, you'll notice that I'm asking you to make one of them a confounding variable. So what you need to do here is make the bar graph for the first experiment, which doesn't have a confounding variable, and make a bar graph for the other experiment that does have a confounding variable, and compare them side by side. And down here, you need to put the 2 levels of your independent variable. So if your independent variable was, let's say, hours of sleep, you would put the hours for group 1 here and the hours for group 2 here. So it might be 4, 8, or maybe 2 hour, 6 hour, whatever you decided. So yeah, these are the 2 levels of your independent variable. Make a y-axis, and then make a bar for the mean of group 1 and a bar for the mean of group 2, and do it for both pages. And then this says, does it look like the confounding variable changed your results? So what you need to do is decide if your results on page 5 look different from your results on page 4. Basically decide if you think that the confounding variable threw off your results on page 5 and made them look different than they did on page 4. Basically, decide if the confounding variable skewed your results and threw off the outcome on page 5. Um, so if the two results look the same, if page 4 and page 5 look like they have the same exact results, you would put no. But if page 5 looks kind of thrown off in some way, then pick yes. And then if you think that page 5 does look skewed or thrown off compared to page 4, then describe how um, your results ended up changing um, on page 5. Basically, describe specifically how the confounding variable threw off your results. So um, if the confounding variable made one of the bars go up or one of the bars go down, or if it made the difference between the bars bigger or smaller, just describe that. Basically, describe how it distorted the two bars, basically. Um, and then on this last page, I just have a few other practice questions. So here we have an imaginary experiment in which we're looking at the effect of classical music on exam scores. So what do you need to do? So we have a classical group and a silence group. One group is listening to classical, one group is listening to silence, and everyone's taking an exam. And time of day is the same for everyone. Um, so what you need to do here is calculate the mean of classical, add the two exam scores, divide by 2. Calculate the mean of silence, add the two scores and divide by 2. And then subtract the mean of classical by the mean of silence to get the difference. So if it's 90 and 70, then you would do 90 minus 70 to get the difference right here. The difference is just how far apart the means are. And remember, time of day is an extraneous variable in this experiment. It's not being studied. We're looking at the effect of type of music on exam score. So decide if time of day is controlled, balanced, or a confounding variable based on what I've told you and in one of the other videos. And here, what I want you to do for experiment 2 is the same thing, except if a person is tested at 6 a.m., imagine that they have, imagine that they get a penalty. Imagine that each person who's tested at 6 a.m. has a 20-point penalty because of being tired. So what I want you to do is take each person's exam score at 6 a.m. and subtract it by 20 and fill the new number into the box. So right here, take 90, subtract it by 20, and get the new number and fill it in.